Okay, so this is Unit 4, Bonding and Naming Compounds. I added this little cartoon here for you guys just to look at the concept of bonding. And we have some male ions that are positively charged, and they're being sucked toward the window, toward the female negatively charged ions out here, the anions. Okay, notice they are nonmetals, and these are all metals. So we're going to talk about compounds and how they can be differentiated by their chemical and physical properties. And we're also going to be looking at two major categories of compounds. Right here. So these are objectives for this unit lesson. So this is lesson 1. Okay, and I'll read this to you if you can't see it on your screen. So it says, perhaps one of you gentlemen would mind telling me just what is outside that window that you find so attractive. Remember, opposites attract. That's what bonding is all about, gaining, losing electrons. And we'll talk about how chemical bonds are formed in the next lesson. So let's review what a compound is. A compound is a substance that has atoms of 2 or more elements that are chemically bonded together. So for example, sodium chloride. Sodium is an element, chlorine is an element. Sodium is a metal, chlorine is a nonmetal. So we're going to look at that and say, why do they attract each other? And a bond is equal to, not equal, but means that they are forces of attraction between the protons in the nucleus. Remember, protons are in the nucleus of one atom and the electrons of another atom. Only valence electrons participate in bonding. And we learned this in the last unit. I tried to explain to you guys that the valence electrons will indicate how many are given up or gained, and that will indicate how much activity an element will have. So bonds are formed as a result of Sorry about that, guys. Bonds are formed as a result of a chemical reaction. Chemical reaction. So, what are we looking at here? The first, law of conservation of energy. There's also the law of conservation of mass and the law of conservation of charge. So we can say that it really applies to all three: conservation of energy, mass, and charge. So during a chemical reaction, energy, mass, and charge can neither be created nor destroyed. So that means that all three are conserved or saved. Okay, some way or another. The octet rule states that atoms bond together to get 8 valence electrons around them. Again, there are exceptions: hydrogen and helium. Okay, can't form a stable octet because they don't hold 8 electrons. They will only hold a maximum of 2. So hydrogen and helium need 2 valence to be stable. Recall, noble gases already have 8, so this is why they don't react or bond with other elements. So which noble gas, helium, neon, argon, or krypton, would be most likely to form a bond with another element? So what you need to do right now is take out your periodic tables, and I would look at the oxidation states, and maybe it will tell you how many electrons are given up or gained. And let's see what that says for us. All right. So the answer is going to be krypton. Krypton is the farthest down in the noble gases out of these choices. And so we're going to say, why do you think that krypton is going to be most likely to form a bond with anything else? And this is because it has the most shielding. So increased shielding. And also it has, so we can say or a non-zero oxidation number. And I abbreviated that. So this is oxidation number right here. So which element, sodium, oxygen, fluorine, phosphorus, or sulfur, would most likely to form a bond with krypton? So now we have to think about which one of these is the most reactive. Which one's going to be the most likely to gain an electron, since these are all, actually they're not, but these are all nonmetals here. This is a metal here, so which one's going to form a bond with krypton? The answer is going to be fluorine, being the most reactive nonmetal, and this is because it has the greatest electronegativity, or ability to gain an electron. Okay, krypton is a noble gas, and it has 8 valence electrons. It cannot gain any more. It's going to give up. All right, so krypton can give up some electrons. So we need to find the one that's going to have the strongest ability to gain that from the krypton, and that is going to be the fluorine. All right, so if we look, okay, I'm going to put this at the bottom here. Krypton, and you're going to add this to your notes, krypton has an oxidation number of +2, which means that it can give up 2 electrons. Okay, and krypton will be most likely to grab one of those, or fluorine would be most likely to grab one of those because it's the most reactive, also highest desire to gain them. All right, so let's talk about energy and bonding. And energy is associated with bonding. You need to either absorb it or it's either released in bonding. Okay, spontaneous bond formation is when energy is released. This is very important. Okay, it just happens. We don't need to input energy. It's actually going to be released and just occurs. So we go from high energy, unhappy atoms, to low energy, where they are happy. Creating a bond creates stability. And that's why we talk about that stable octet, stability. So exothermic, X means outside or to release, and therm would mean heat or temperature. So when energy is released as a product, then we are talking about an exothermic reaction. So exo, or we could say X, meaning outside or to release, and therm, which would mean heat, temp, or energy. All right, so here is just an example. We have one compound A, or substance A, plus substance B react together to form or yield product C, which is a new product, and release of energy. So that would be in the form of light or heat, generally in combustion. Okay, when you burn something, energy is released. So note, energy on product side of arrow. So these are your reactants over here. And everything on the right-hand side of the arrow are your products, what is being produced. So for example, we have an equation here. We have calcium chloride reacts with sodium bicarbonate to produce calcium carbonate, carbon dioxide, sodium chloride in an aqueous solution, so this would be salt water, plus heat, which is your energy. It is a product, it is on the right-hand side of the equation. Therefore, this is an exothermic reaction. Heat on the right-hand side, or any type of energy on the right-hand side of the equation, this isn't the equation, would indicate that it's exothermic. Now, breaking bonds, which is not spontaneous, energy is going to be absorbed. We go from low energy, happy atoms, to very high energy, which means they're unhappy. Ripping the two atoms apart takes energy. Anytime you think of Velcro, you need to input energy to pull those two pieces of Velcro apart. Endo, so this is going to say, this endo means within, or absorb, we can say. And thermic, again, would be heat or temp. Right? So endothermic means that energy is consumed or absorbed or needed as an ingredient to fuel the process. So here we go. We have substance A, we input some sort of energy, heat it up, and then we end up with new products B and C. So remember, again, we have to know reactants, what is being reacted together, and then your products, anything that's on the right-hand side of the arrow. Note, energy is on the left now. So it is on the reactant side. Of the arrow. So here's a everyday example for you, an ice pack. So for those of you who play sports, chemicals combine in the ice pack, bonds are broken, energy is consumed, you feel cold because you're losing heat to the ice pack. Remember, your body is warmer than the ice pack, so generally temp or energy goes from, or heat will go from high to low. So the heat is being absorbed by the ice pack, and that's why the ice pack gets warm over time, because your body feels cold from the transfer of the energy. Okay? Next, so the two most common types of compounds. The first one, ionic. So compounds are formed by the transfer of electrons. This is very important. Ionic compounds, transfer of electrons. So one gains, one loses from one atom or polyatom to another. And we're going to look at what polyatoms are in a second. So here's one example. A metal will lose an electron to a nonmetal. So here's a good example. Sodium chloride. Sodium has a +1 charge. It will give up 1. Chlorine has a -1, so that means it will gain that. So they will bond together because one, it balances the charges out. So there is a conservation of charge there. 2, metal loses an electron to a polyatomic ion. So this is NO3, which has a -1 charge, and sodium has a +1. Therefore, these two will bond. This will give up the electron to the sodium, the nitrate ion, and this electron will be gained. Okay, so this says it will gain 1, this will give up, and therefore the bond will occur through a chemical reaction. So here on table E, and I put it on here for you guys, not on your notes, so you have to look at your periodic table. Here are polyatomic ions. What this means is that they are made up of more than one type of ion. So poly meaning many, okay, or more than one type of element. And they are ions because they don't have a balance of charge, so therefore they get their own charges here, just like a normal ion, so that's why they're called polyatomic ions. So for instance, our hydronium ion, you have 3 hydrogens and an oxygen, and the overall charge on that ion is a +1. So this would bond with anything that has a -1 charge or oxidation state. The nitrate ion here, NO3-, and this is what we just did in our example, can bond with anything that would give up an electron so that this would gain one for bonding. Okay, and we're going to look at some other ones here. Generally, they are, a -1 or a +1 charge. Sulfate ion has a 2-, so this will bond with anything from group 2, okay, because group 2 metals will give up 2 electrons, and sulfate ion will gain 2 electrons. So here, group 2 metals like to bond with these. And same thing with anything that is a -2, carbonate. Okay, anything that's a +2 will balance out the -2. All right, so here's another type of ionic bond. Polyatomic ion loses an electron to a nonmetal. That's the polyatomic ion that would have a positive charge, and then bond with a nonmetal that has a negative charge. That means this gives one up, this one gains one, and therefore the bond can occur. Fourth example would be a polyatomic ion with another polyatomic ion. Obviously, charges have to balance. Conservation of charge, +1, -1, so the overall charge is equal to 0, which tells us that we have a conservation of charge overall. All right, and the second type of bond is called a covalent bond. Covalent meaning sharing, and then valence, sharing the valence electrons. Compounds formed when 2 or more nonmetals share their electrons. Remember, we're always talking about valence electrons in bonding. So here we have methane, and some of these actually are listed on your reference tables as well. But methane can form 4 bonds, therefore it will bond with hydrogen to share these electrons. So each line represents the sharing of 2 electrons. So here's 2, 4, 6, and 8. Stable octet. 2 on the hydrogen, remember that's the exception, so there's 2 on this, 2 on that, they're all happy. So here we go, we have water, and there are there's 2 sets of electrons, or a total of 4 electrons that are not being shared or bonded, so it gives it kind of a charge or a polarity, which we're going to talk about in our subsequent lessons. But right now, each line represents a total of sharing of 2 electrons. So we have 2 shared here, 2 shared here, and then you have these other 2 to indicate that oxygen is stable. So there's a total of 2, 4, 6, and 8 to make that stable octet on the oxygen. So when we bond, we have to make sure that everything is going to be stable, because then that will give us a conservation of charge as well. So remember, 2, 4, 6, and then these 2 up here, 8, will show that we have the stable octet on the nitrogen. Hydrogen, remember, it can only have 2, because it only has 1 energy level. And so let's summarize this to end our lesson. Metal plus a nonmetal is ionic. Metal plus a polyatomic ion is also ionic. A nonmetal with a polyatomic ion, also ionic. Notice how many of them are ionic. And then polyatomic ion with another polyatomic ion. Remember, opposites attract, so this one would have to be negative charge, this one would have to be a positive. Same thing. And here, nonmetals are going to be negative, polyatomic ion has to be positive here, this would be positive, this is going to be negative, and then we have a positive metal with a nonmetal. And their charges have to balance, so if you have a +2, this has to be a -2. That's how we determine what will bond with what. And then finally, our second classification, we have a nonmetal plus a non-metal. We call those covalent bonds. Now we're going to talk about something a little different. There are also metallic bonds, okay? And the metallic bonds are substances that are found on the left of the staircase. And they can share mobile electrons, because electrons are mobile. So we're going to finish this lesson, and we're going to talk about metallic bonds for lesson 2.